Hello everyone, welcome to lecture number 2 of engineering mechanics. In previous lecture, we have learned about the definitions of engineering mechanics, statics, dynamics, kinematics and kinetics. We have also learned about the dimensions and units used in engineering mechanics. In today's lecture, we are gonna discuss about the laws of mechanics, force and force system. These laws of mechanics are the basic principles which we use in engineering mechanics to understand force, and these principles are also useful while we calculate the numericals. Now let's see one by one. Newton's first law. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. Let us say there is a body which is at rest position and a force is applied on that body, and this body start moving in the direction of force applied with the velocity v. Or let us suppose a body is already moving with a velocity v and we applied a force in the opposite direction to the motion of that body. This body comes to rest position, which means whenever we have to move a body or destroy the motion of a body, we have to apply a force. First law contains the principle of the equilibrium of forces, which means every body is in equilibrium position unless its equilibrium gets destroyed by some other force. In this figure, you can see that this is a sphere resting at this position, also acted upon by these three forces of 15 Newton each. The net resultant of these forces on this sphere is 0 at this moment. But if we vary one of these forces, let us say instead of applying 15 Newton, we are applying 20 Newton force in this direction, then the equilibrium of this sphere get destroyed and the body will start moving in the direction of the resultant force. Newton's second law. Newton's second law states that rate of change of momentum of a body is directly proportional to the force applied to that body. In this law, there is one term, momentum. We know that the formula of momentum is mass into velocity. This is the momentum. Now let's suppose there is a body having a mass m acted upon by a force in this direction, and this body start moving with the velocity v in the direction of force applied. Now this law states that the rate of change of momentum is directly proportional to the force applied. Means this F, which is force, is equal to derivative of this momentum, the rate of change of momentum. As we know that mass of this body is constant, So we take out m from this derivative and it will remain dv upon dt, which means rate of change of velocity. And we know that rate of change of velocity is nothing but acceleration. So we replace dv upon dt by a in this equation. Now the formula becomes F is equal to m dot a, means force is equal to mass into acceleration. So the second law gives us the formula to calculate the force. Newton's third law. Newton's third law states that to every action there is equal and opposite reaction, which means whenever we apply a force on any object, a reaction force will be act in the opposite direction and will be equal to the action force. As in this figure, when this rocket exerts a thrust on the ground, then the ground in return exert a reaction on this jet, which helps this jet to take off. Similarly, when we hit a ball on the ground, it will get bounced by the reaction. So, as per this law, to every action there is equal and opposite reaction. The gravitational law of attraction. Newton's law of universal gravitation is usually stated that every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Let us say this is a body 1 and this is a body 2. Body 1 is having a mass m1 and body 2 is having a mass m2. And these two bodies are separated by the distance d. Now this body of mass m1 will exert some force on mass m2. Let us say this force is F1. Similarly, this body will exert some force on this body of mass m1. Let us say this is F2. Now the force exerted by each body on the other is equal. F1 is equal to F2 is equal to Fg, this one. And it is calculated as capital G m1 into m2 divided by d square. Product of their masses divided by the distance, square of the distance between them. And this G is the universal gravitational constant. Law of transmissibility of force. It states that the condition of equilibrium or of motion of rigid body will remain unchanged if the point of application of force acting at a point is transmitted to act at any other point along its line of action. So this law states that whenever we applied a force on a rigid body, this term is important, rigid body. Let us say we are applying a force F at this point. Let us say this is P. This is the line of action of this force and this force is acting in this direction. If we change the point at which the force is acting, let us say Q, from here to here, on the same line of action and in the same direction as the previous force, the net moment of this body will be equal to this body. This will move in this direction, this will also move into this direction. So this is the law of transmissibility of force. We can transmit the point on which the force is acting on any point along its line of action and in the same direction of the force. The net resultant will be the same, or we can say the moment of the body will be same, will remain same. The only assumption in this law is that the body must be rigid, otherwise it get deformed. Next is law of parallelogram of forces. The law of parallelogram of forces states that if two forces acting on a particle at the same time be represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, their resultant force is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. Which means, let us suppose we have a body and two forces are acting like this, but they are acting on the same point, let us say. So according to this law, if these two forces be represented in magnitude and direction by the two adjacent sides of a parallelogram, which is OA and OC, then the diagonal of this parallelogram will be the resultant of these two forces. This R will be the resultant of these two forces. So these were some basic principles we use in engineering mechanics. Now the main thing in engineering mechanics is the force. As we are talking about the force and will calculate the force in engineering mechanics in different situations. So the first thing is, what is force? Newton's first law already defined the force, which says that it is the agent which produces or tends to destroy the motion of a body. In simple words, we can say that force is a push or a pull. As you see in this diagram, one person is pushing the object and the other person is pulling the object. Basically, they are only exert some force on this body to move it from one point to another. Mathematically, we saw that as per the Newton's second law, the formula of force is F is equal to m into A, which means mass into acceleration. The SI unit of force will be Newton, the SI unit of mass will be kilogram, and the SI unit of acceleration is meter per second square. Now comes the force system. A body may be acted upon by a single force or a number of forces depending upon what kind of force system that body is experiencing. Force system is basically divided into two parts: coplanar and non-coplanar. Coplanar means co, same, and planar means plane. If we see the axis diagram, x, y, z axis diagram, we know that there are three planes, namely xy, yz and zx. So coplanar means that the force are lying in the same plane, means in one plane. Maybe it is xy or yz or zx. On the other hand, non-coplanar means that they are not lying in the same plane. They are lying in two or three planes simultaneously. Coplanar force system is again divided into four parts: collinear, concurrent, parallel, non-concurrent, non-parallel. Similarly, non-coplanar also divided into three parts: concurrent, parallel, non-concurrent and non-parallel. Let's understand these types of force system by some diagrams. First is collinear. Collinear means that the line of action of the forces will be same. Forces can be in the same direction or they can be in different direction, but the line of action will remain same for all the forces. That's collinear force system. Coplanar parallel means this is the plane and all the forces are acting in this same plane. So these are coplanar and they are parallel to each other. But one thing we have to note here, that the direction of some forces are downwards and some are upwards. So these are unlike parallel forces acting in the same plane. Whereas as we see in this diagram, again the plane is same, forces are parallel, but they are all acting in the same direction. So these are coplanar like parallel. Next is coplanar concurrent. Forces acting in the same plane and they are acting at the same point also. So they are coplanar concurrent. Next is coplanar non-concurrent. Means the force lie in the same plane but they are not acting at the same point. They are acting at different points. So these are coplanar non-concurrent. Next is non-coplanar parallel. Means that forces are not lying in the same plane, they are lying in different planes, but they are parallel to each other. Non-coplanar concurrent. Again, non-coplanar means they are not lying in the same plane, but they are acting on the same point. Non-coplanar non-concurrent. Non-coplanar means they are not lying in the same plane, and non-concurrent, they are also not acting on the same point. They are acting at different points, as you see in the diagram. So that's why these are non-coplanar and non-concurrent. So these are some basic system of forces. So in today's lecture, we have learned some basic principles of engineering mechanics, which we used in the rest of the lectures, and force and force system. So that's all for today's lecture. Happy learning.